Hi one and all, welcome to my YouTube channel. In today's video, I'm going to discuss and demonstrate about the network topology which I have created for an organization that has two offices. One is headquarters site and the other is branch site. As we can see in the diagram, the headquarters site router and the branch site router is connected to ISP, which will provide internet access. Both the sites have servers, computers, for staff and computers for guests, which are connected to their individual routers. I have also connected a web server component and attached it to the ISP router that will exhibit any web server on the internet. On the right hand side, there is a legend that displays all the IP addresses and network ranges for the devices and objects. So in this topology, I have configured a tunnel mode VPN that will provide a secure tunnel between the headquarters router and the branch router. I have also defined several access lists that will allow access to internet, and those access lists will also restrict access to certain resources. I have used overloading NAT to translate the private IP addresses into public IP addresses and vice versa whenever any computer wants to connect to internet. So as we all know that netting can be useful when we want to mask our private IP addresses. That is basically we want to secure our private IP addresses and we don't want it to be exposed on the internet. So net can be useful in such scenarios. Now we will have a look at the policy requirements which are which were required to create this network topology. As we can see that the requirement says that we need all the staff computers at the headquarters site to have access to the servers, and they should also have access to internet. All the guest computers should have access to internet only. All the staff computers at branch site must have access to servers at the headquarters site, and our site-to-site VPN must be configured such that the data is kept confidential. All the staff computers at branch site should have access to internet, and guest computers should have access to internet only. All access to internet must connect via NAT. So I have considered all these policy requirements and configured the network topology accordingly. First, I would like to demonstrate the tunnel mode VPN, which I have configured between both the routers. So I'll navigate to the headquarters router and demonstrate the policy which is configured for tunnel mode VPN. As you can see that I have configured AES 256-bit encryption, SHA hashing algorithm, pre-shared key for authentication, Diffie-Hellman group as 5, and lifetime as 86,400 seconds. So basically, whenever a data packet will be transmitted from one side to another, the packet will be encrypted using AES algorithm. SHA hashing algorithm will be used. Diffie-Hellman group 5 will be used, and authentication method is pre-shared key, which means that a pre-shared key will be shared between both the routers, which will help both the routers to authenticate each other. Now we will try to send a ping request from branch computer to the headquarters server. Since the VPN establishment may take some time, so initially we won't get the response from the headquarters server, but once the connection is established, we can easily get the ping response. So I will have to try a couple of times to send the ping packet to the headquarters server, and once the connection will be established, ping server will be received at our end. Okay, so I can see that I have received one response. Now again, I will try to ping and I can see that I am receiving successful response. So this means a secure tunnel has been established between both the routers. Now let's look at the security associations. As we can see in this table, a security association is been established between both the routers, wherein the branch router is the source and the headquarters router is destination. Now we can check the same table on the headquarters router. So here we can see that there is a active connection, but instead of branch router being the source, the headquarters router is the source IP address and destination is the branch router. So this ensures that there is a secure connection established between both the routers. We can also have a look at IPsec security association, which will display the number of packets that were encapsulated, encrypted, decapsulated, and decrypted during the data exchange. So we initiated the ping response from, since we initiated the ping request from branch computer, branch staff computer, we can see that there are several packets which are encapsulated and decapsulated. Now we will look at the other policy requirements. Here, the policy says that the staff computers should have access to the servers at headquarters site and they should have access to internet. So, so we will have a look at the access list which I have configured to allow those rules. As we can see here, I have defined an access control list which will allow the IP address range of staff computer to access the servers, and also it will allow access to internet server. So let's try to ping from staff computers at headquarters site. This is the IP address of the headquarters server and I am getting successful response. And this is the IP address of our internet server. And even this is giving me successful response. Now we will try to send ping request to any other computer in the network. For example, the staff computer at the branch site. As we can see that since we have already defined only two permit rules for the headquarters server and internet server, the router will not allow me to access any other computer in the network. Similarly, we can check at the desk computer on the headquarters site and it should be able to access internet only. So this is successful. Now I'll try to access the server at headquarters site. And because of the rules defined in the access control list, it won't allow me to access the server at headquarters site because I have allowed only internet server. Now similar configurations are also done at the branch side. So we'll just have a look at the access control list, which are defined on branch router. As we can see here, I have defined similar rules in the access control list wherein the staff computer will be able to access internet and it will be able to access the server available in the headquarters site. For guest computers, I have only defined access for internet server. Now, another requirement in our policy says that whenever the computers are trying to access to internet, we should use NAT. So for that, I have defined NAT rules on both the routers, which will ensure that whenever the staff computer or guest computer tries to access internet, netting will be used, which means that the private IP address will be masked and the public IP address will be used in that place. So I'll try to ping the internet server from guest computer and we will check the IPNet translations which will have taken place on the headquarters router. As we can see in this table, this is the inside local IP address, which is the IP address of my guest computer. Inside global IP address means the IP address of this interface of router which is connected to ISP. So this is basically the external IP address. Outside local and outside global IP address are the IP addresses of internet server. So this means that whenever internet server will receive the ping request packet from guest computer, the source IP address won't be the private IP address or internal IP address of its own. Rather, it would be the external IP address that is the IP address of this interface, which is connected to ISP. Now we can also have look at the NAT rules which I have defined, and we can have a look at that in the running configuration file. So for NAT, initially what I have done is I have configured the interface of the router which is connected to staff and guest computer as NAT inside, because those will be the internal interfaces or inside interfaces, and this interface of router which is connected to ISP will be configured as outside interface. So we can see that in the configuration here. Now I have defined an access list which will allow the IP address range of staff computers and guest computers to access the internet. So this is the access list for that. I have also defined a pool of IP addresses that will be used by the router for NAT translation. So since we have only one IP address allocated to this interface right now, I have just defined this IP address. And then I have defined the NAT rules, which says that the source of IP addresses would be taken from this access list, and it will use the IP address from this pool to overload the, or basically to translate the IP addresses. So here I have used overloading because the source IP addresses would be from multiple computers, but there will be only one IP address which will be used for translating or for masking. So I have used overloading that. So that's it for the video. Hope you liked it. Thank you so much.